Okay guys, I had this video done and it was about an intake manifold. It was only 5-8 minutes, something like that long, and drawing in air into an intake manifold in a petrol car. But when I was looking at it and editing it and just sticking bits together to put them on YouTube, I kind of realised that one or two people had asked me before on an open course I had done about fuel trims, and that they were kind of starting to learn a little bit about fuel trims. What I'm going to try and do before I put up this video, and this is the talk that's going to happen here, I'm going to try and point out or maybe educate lads. I wouldn't even say educate because I'm no guru. Don't take me as being the gospel. I'm only just giving you what I know to try and help ye and your very educated lads who could find the loopholes and gaps in what I'm saying, but the basics of it is going to be this, okay? I have it drawn out here on a whiteboard and I'm going to show you what is a fuel term, long term and short term, and total fuel trims, okay? I might be able to get this across quite right, but we're going to give it a shot and you can see what you make of it and let me know, okay? Okay. Standing here, fuel trims. What's happening is we have an engine, but because that's fuel injected and electronic ignition, it needs a thing called an engine ECU. The engine ECU is the black box of electronics that's going to control everything that happens down here. Now, basically, the long and short of it is when that engine is running, because this is allowing it to run, what we're going to have is exhaust emissions come out and down here. Now, this is the exhaust system, and that's the catalytic converter, catalyst we're calling it here, and this is going to be the upstream lambda sensor. So if you can get that, the way I've drawn it, maybe I should have wrote in there lambda as well. Upstream lambda sensor, downstream lambda sensor. Now, what happens is when your car is started and running, what's happening is this lambda sensor is relaying information back to the engine ECU. And back to it, and back to it, and back to it. It keeps getting refreshed. And while that is happening, what's happening is your engine ECU then is adjusting the injector on time. So the petrol fuel injector on time in that engine to give it more fuel or less fuel, or more fuel or less fuel from the information it's getting from the lambda sensor. Now, what the engine and manufacturers and all that kind of stuff want is the perfect burn, which is stoichiometric. Stoichiometric is 14.7 parts of air to 1 part of fuel. Right, so this is what they're chasing after here all the time. But because of the wide range of loads and speeds and all that stuff that your engine is put to, as in stopping, coasting, driving hard, driving slow, they can't achieve stoichiometric all of the time. So they'll get it as close as they can through this lambda sensor by monitoring it. Okay? Now, over here, as we said, 14.7 to 1 at idle. We'll hypothetically say we have 10 grams of air per second going in. Okay? Hypothetical now this is. At idle. Then maybe at 2,000 RPM or whatever it might be, the quantity gets a whole lot greater. So we're saying it doubles, 20 grams of air per second. It doubles. So that 14 parts of air, in theory, it's the mixture we're talking about here. The amount or the quantity of it gets bigger. But the same 14.7 parts of air want 1 part of fuel or as close to that, because that is stoichiometric. Now, the lambda sensor that is stuck in here is going to be giving us a signal like this. This is a narrowband sensor we're talking about here, okay? Just a 4-wire narrowband sensor. We have 0 volts, V, with my bad left hand, V. Right, down here, the lambda sensor is going to monitor how much oxygen or lack thereof in that exhaust system. And by seeing a small, I'm going to go backwards. By seeing a large quantity, oh gosh, I'm lean here anyway. So lean is a large quantity of air and a small quantity of fuel. So when it sees a large quantity of air, the voltage gets low, okay? And what happens then is your engine ECU sends out a trigger, hey, send in more fuel. So it switches on the injectors for a bit longer. And by sending in more fuel, then all of a sudden, this will change. It'll see a rich condition, change it to rich. This is too rich. It'll switch it down again. So all the time in the lambda sensor, you're going to see lean, rich, lean, rich, lean, rich. Okay, that's why I had rich wrote up there and I have lean wrote down here. So the lambda sensor is going to be doing that, trying to achieve that all the way along. Now, so that's what's happening. According to your engine wears, they say that's fairly close to stoichiometric along the middle, but they can't get fairly close to it. And better with the wide band sensors, but for now, this is what we're talking about here, the easiest one. As that engine wears, so the engine ECU is sending in a certain amount of fuel, 1 part to every 14 parts air it sees, because it's monitoring the amount of air is going into the engine, and that's what's making it send in a certain amount of fuel. According to your engine wears, we'll just say it starts to burn a slight little bit of oil. So out the exhaust system, it's getting a little bit richer over time. Now, a long period of time, it's getting a little bit richer. Or your airflow meter, maybe I should have drawn an airflow meter here. Your mass airflow meter is getting a little bit dirty. So it's actually not giving an exact or as exact a reading of the amount of air going in when the car was new as in cross-reference to when it's 3 or 4 or 5 years old. So it sees over a long period of time, it sees a richer flow of exhaust gas down here. Now, it doesn't want to see your lambda sensor getting richer all the time and only using maybe 0.3 of a volt to 0.2. It doesn't want to see that. It will adjust its fuel trims, okay? And the fuel trims are where the engine ECU is going to see what's happening over a long period of time. If it's happening over a long period of time, it's going to adjust the long-term fuel trim. Now, it will only adjust the long-term fuel trim after it adjusts this. So it adjusts the short-term first. This changes faster over a shorter period of time. Once it sees this at 10, 15, 18, whatever it may be, for a good while, it will adjust the long-term up. So the long-term will go up, and if the long-term goes up, this can go back to 0. So if you see on your long-term 10 and your short-term 0 fluctuating, because that moves quite fast, nearly like the lambda sensor signal up there, that moves quite fast. And when that's moving quite fast, this can be very, very slow. Could take a long drive. The problem there are an intake air leak or an exhaust leak or something strange going up here, mass air flow meter after failing. It can take a long time for that to come back to right. But if that's plus 10, the short term will have to go negative after you fix your problem up here. And by going negative, it plus 10 and maybe minus 10 will give us a number of 0 for our total trim if we had a problem and if we fixed it. Over time, as you're driving the car and working with the car, your short terms will always be moving. They like that short-term fuel trim to be under 10. Same thing up here. I can't tell you to be exact, but I would say if you had a total trim of around 10, you might be happy enough. That's kind of maybe 5 or 6, 3 or 4, perfect. If the engine is worn, this will be standing up higher, or if there's a split pipe and it's going on for months and months and months, and this thing, it doesn't want to be switching and changing this short term all the time, and it just brings that to a hypothetical number that in theory fixes the engine problem that's concerned about, trying to fix that. Kind of gone wrong even myself there, but you can get kind of, I'm hoping that you can get the gist of where I'm at or what I'm trying to elaborate. Now, on the car that's coming up, we had an intake air leak coming in here, okay? Now, when this car is ticking over and we're bringing in 10 grams of air per second, if we're bringing in a certain amount of air, as we said, in there, oh gosh, I'm gone wrong. Pay no attention to that. Dave's there will be giving out where I'm at here. We have actually an intake manifold here, okay? And we have a leak in here at our intake manifold. So here we have the leak in. Scrub that, lads. Here we have the leak. I'm making a mess in my board. Marker's still wet. Here we have the leak. So we have some unmonitored air getting in here. It's not being seen by the mass airflow meter, okay? I'll go out here. F. It's not being seen going in here by the airflow meter. So we have 10 grams of air per second being seen going in. We're putting in enough fuel for that 10 grams of air, but really we have maybe 12 grams of air per second going in. So what we have here on this car is a lean condition, because there's more air getting in than what the actual engine ECU sees. So it mixes in enough fuel for the 10 grams of air, and that gives us a lean condition because there's more air going in. So in theory, this quantity of stuff gets bigger, which makes this smaller, if that makes sense. So our airflow quantity with a problem in here grows, okay, at idle. Hence we were getting, I think it's a P0171, I think, I don't know, I'm going out of my head now, so be cool and kosher with me on that. Now, if we're looking at our fuel trims, our short-term fuel trims, we will say would be plus, will we say 20? Plus 20. Now, when we bring up our engine revs, so if we bring the engine revs up, when we come over here to this graph at 2000 RPM, that same quantity of air that's getting in here is not as big a deal here. So up here it's quite big, but here it's only half as dramatic for the engine because the engine speed is doubled, the engine air volume is doubled, and the little bit of air that's leaking in here on the intake manifold is not as big a problem. So we will see this plus 20 fuel trim go down maybe to plus 5 when we bring the engine revs up to 2000 or so. So according as we bring the revs RPM, according as we bring the revs up, it's not bothering it as much, that intake manifold leak. I don't know if that makes sense. I'll zoom out, and if anyone wants to take a screenshot of that, maybe at this point they can see it. That's probably off my cuff anyway, right fast. Best explanation of my fuel trims and the way it's happening. Okay, but they're a very handy tool. The fuel trims are a very handy tool to see what's happening and where that leak is coming. If it's plus numbers on the short term and or the long term, and look at the short term, don't ever pay too much attention to the long term, only over a big long drive cycle. But on your initial repair, whoever is going to be fixing the car, it's the short term we're focusing on. If we bring our engine revs up and the short term fuel trims don't improve, well, it's not an intake air leak, it's something else that's causing the problem. But on this occasion, it's an intake air leak that's getting better as we bring the engine revs up, and also improving as the engine gets hotter, because the metal in the head is expanding and closing that gap that's in the manifold gasket, if there is a little bit of a thing. That's my cut on fuel trims. So look, if you want to keep on watching, keep watching for the video to come, or I'll put this at the end of the other one as bonus footage, okay? Whatever way we'll figure it out. But here I am doing my analogy or my explanation of fuel trims. All right, guys? Please like and subscribe if my hints and tips are any good to you, and I will talk to you in the next cartoon. Peter Kennedy, signing out. Talk to you later, guys.